Our next presenter is also online, Tess, explaining factors of wildlife train collisions and use of underpasses and overpasses not detected to wildlife by wild ungulates in northwestern France. So Tess, whenever you're ready, you can go ahead and display your presentation.
Okay, thanks.
And I will, at 3 minutes, I hope you guys can see, I will put a card up in front of the camera at 3 minutes remaining, and then at 1 minute, I'll break in and tell you you have 1 minute.
Okay, thank you. Yeah, I can see you, yeah. Okay, so good afternoon, everyone. My name is Tess HEYDORFF-DECAUX, and I'm here to talk about my PhD research at the Paris 1 Panthéon-Sorbonne University in collaboration with SNCF Réseau, which is the France's main railway infrastructure manager. So my PhD research is focused on assessing the barrier effect of railway infrastructure on wildlife movements. Compared to roads, which has been widely studied, railways have some distinct features that may influence animal behavior and limit the direct transferability of road-based findings. For example, tracks are narrower than highways. Most lines are unfenced. Train traffic is often intermittent and relatively low. And the stone track bed may seem more natural than asphalt surfaces. The barrier effect of railway networks leading to habitat fragmentation and increased wildlife mortality has been well documented for over 2 decades. Biodiversity impacts are increasingly considered in new rail projects, especially high-speed lines that include, for example, dedicated wildlife crossings. But this is rarely the case for the existing railway network. So most of it was built in the 19th and 20th centuries and is mostly unfenced. So to give you an idea, in 2023, SNCF recorded over 10,500 collisions with wild ungulates, such as wild boar, roe deer, and red deer. And this number has been steadily rising since 2015. Given this context, my study aims to analyze the interactions between railways and wild ungulates movements, especially wild boar and roe deer, from 2 perspectives. First, identifying conflict areas where tracks crossings lead to collisions, and second, examining area of safe passage through overpasses and underpasses. To go more in depth, our first goal is to explain the spatial distribution of collisions, assuming they result from multiple interacting factors across scales. First, at the landscape scale, we test whether collisions are more likely in areas of high functional connectivity and in place without under or overpasses not dedicated to wildlife. These regional patterns are examined together with local factors, including fencing, which can divert animals, concentrate collisions at fence ends, or trap animals on the tracks. Track width, which affect how long animals are exposed to risk, and track curvature, which can affect animal visibility. In parallel, we explore whether existing crossing structures, originally built for vehicles, pedestrians, or waterways, can function as safe passageways for wildlife, even though they were not designed for that purpose. To evaluate their potential, I deployed camera traps on video mode at 40 such structures along a railway line with frequent collisions in northwestern France. These structures differ in size, surrounding landscape, and distance to known collision hotspots. So data was collected for 3 2-month period over the course of a year. Video were analyzed using the AI software DeepPhone. And for videos featuring wild boar and roe deer, I manually recorded key events and behavior, including approaches to the structure, feeding or foraging, and successful or failed crossing attempt called retractation. So our initial video analysis shows that roe deer interact much more frequently with wildlife crossings structures than wild boar. For roe deer, we recorded nearly 700 individual detections, including 116 successful crossings at 10 different structures and 27 retractations at 8 structures. The 3 structures with the most activity, both in successful and failed crossings, are shown here. So they include 2 overpasses and 1 underpass. Wild boar, in contrast, were detected around only 330 times and showed very limited interaction with the structures. We only observed 4 successful crossings, all at 2 small underpasses. Their most common behavior near the structures was foraging. So this represented almost 60% of the events recorded for wild boar, compared to just 24% for roe deer. The next step is to figure out what makes some structures more successful than others, especially for roe deer. And we'll be testing a combination of landscape factors, such as functional connectivity, track's position relative to the ground. Yeah, thanks. And we'll see whether collisions are less frequent in areas where structures are actively used. And then we'll test local factors, including substrates, availability and variety of palatable vegetation, and presences of obstacles or guidance near the structure. And so to finish, based on these findings, our final goal is to develop a practical tool for railway managers, allowing them to replicate the study in other regions. Thank you for your attention, and please feel free to ask any questions now or reach out to me later.
Thank you. Any questions for Tess? Okay. Oh, wait, we got one?
Yeah.
Yep. I can repeat it if you can't hear it.
Yeah, I'm not sure I will hear it.
Hi, Tess. Thanks for the presentation. I was wondering if, not quite related, but adjacent, if you thought about looking into the use of alarms and also potential mitigation.
He was asking about the use of alarms for mitigation. Is that
yeah.
Okay.
This is another field of research that we are doing at SNCF. So I'm not doing it in my PhD, but yeah, we work into that also in scaring devices for wildlife, if that's what you mean.
Yes, thank you. Yeah, thank you very much.
Thanks.
Thank you.